Hey friends, welcome to follow up. Today let's have a look at problem 146, least recently used cache. In this video, we're going to explain a solution based on OrderedDict. So in other words, again, we're going to use data structure to help resolve the problem. So this problem is basically now a classic problem. So here it says that we would like to design a data structure that follows the constraints of LRU Cache. So here we are going to implement a class, which contains three methods. So one is the initializer, right? So it accepts a argument and capacity, and the other is a get method. So given a key, we're going to check if the key exists in the cache. So in other words, there is a hash hit. Otherwise, we're going to return -1. So the third one is a put method. So given a key and a value, we're going to update the value of the key if the key already exists. Otherwise, we're going to add the key value pair to the cache. So if the number of keys exceeds the capacity from this operation, so we're going to evict least recently used key, right? So the functions get and put must each run in O1 average time complexity. So this is the requirement. So largely we can understand this LRU cache with some dictionary mechanism, but as the void and the put method indicate, so there's an order, right? So we want to evict the least recent used key. So in this case, so we have an order. So typically, the full implementation of such a cache involves a doubly linked list. So here, what we are going to use is OrderedDict dictionary, right? So essentially, there is the same thing. So here is an example, right? So you can check all these things, and the constraints are the following: so capacity, in key, and value, and this is the number of calls upper bound, right? So with that said, we are ready to look at the coding part, and in between, we're going to explain the logic. So here the strategy is that, so we're going to use ordered dictionary, OrderedDict. So in a full explanation implementation, so you can think of doubly linked list. There are actually such implementations available in some books, but it's actually a good exercise to try by ourselves for doubly linked list implementation in a full capacity. So again, with that said, this problem here, or this video, through this video, we're going to demonstrate the use of data structure to help address problem. So with that said, let's moving towards the code. So here, let's first look at the initializer, right, a constructor. So here we have self. So first I'm going to use a capacity. So this will be the capacity input. So this is the how many elements it can be included. It can contain, right? So also I'm going to use a size variable to check against the capacity. If size is greater than capacity, we're going to evict element, right? So another one is the data, right? So we're going to use collections, that's the ordered dictionary, right? So this you can understand this. We have a dictionary, but it has order, right? So with that said, let's look at the other two methods. So the first one is get method. So basically, we want to, given a key, we want to see if the key is in the cache or in the dictionary. So this is actually very routine, right? So in self data, if key is in self data, and then what we're going to do is first get the value, right? That is self data key, right? So now after we do this check or this retrieval, and then this key value pair is the most recently used one, right? So what we are going to do is we first del this key and value pair, and then we are going to add it in the end, right? And then what we are going to do, we are going to do self data and key is the value, right? So this way we finish the check, and also we know this key value pair is the most recently accessed one. So we are going to put into the tail, or you can see the tail depending on your convention of the data structure. In other words, this part or the dictionary. So this part, these two lines of code are important. So we need to return this value, right? So for the cache, the retrieval result. Otherwise, as explained here, so we're going to, as a request here, we're going to return -1. So this two part is important. So let me put a star here. So this basically after you retrieve the key value pair. So if the key is were in the cache, so then the key value pair will be the most recently used one, right? So we are going to put it in the correct order. So this is the get method. So now let's look at the put method. So notice that in the put method, we need to also check against the capacity. If the capacity is larger than allowed capacity, we're going to evict operation. So for this one, let's see, there's two possibilities. One is key is not inside the cache. So in this case, we just need to add the key value pair to the end, right? So otherwise, we need to update. So, but we need to also adjust the order, like in the get method. So if key in self data. So in this case, so we're going to see self data key. This is the update, right? So to be value, and then we need to move this key value pair to the most recent one, because this key value pair will be regarded as most recently accessed. So in this case, we're going to see self data. So move to end. So we are going to move the current key value pair to the end, right? So this is the case when we have a cache hit. So otherwise, so else, so this case is a cache miss, right? So in this case, what we are going to do is we are going to see self, because in this case, another point to notice that because we are updating, so there's no change in the number of elements in the dictionary, so we don't need to update the size and compare against the capacity. So here in the second case, we have a self cache miss case. So we add a new pair, right? Key value pair. So in this case, we need to update the size. Self size is incremented by 1, right? So then we need to check the size, current size, against the capacity, right? So if previously we already have capacity number of elements, then adding this new one will have an extra element. So we need to evict the least recent used one. So let's do this check. So if self size is greater than self capacity, actually it's nothing but self capacity plus 1 due to the mechanism we are writing the code. Then what we are going to do, we are going to do self data pop atom. So we are going to pop from the very beginning. So we're going to write last equals false, right? So in this case, so after we do the pop operation, so we're going to update the size. It's decremented by 1, right? So this is the third method, the put method. So here, this return, there's no specific return, so we just end here, right? Or if you like, you can write return, but without anything returned. So with that said, basically that's one implementation of the least recent use cache. So here we are using ordered dictionary, right? So in other words, it's in a rigorous sense, it's not a full implementation by doubly linked list, but this piece of code, these pieces of code will help us understand the least recent used cache mechanism. There are some other cache, like most frequently used cache, right? Other variants. So actually, those are also good to digest and good to know. So with that said, let's first do a test. Yeah, it passes the given example. Now let's look at the generic case. So it passes all generic cases. So here are 2 points to be noticed. First, in the in the constructor, so we used ordered dictionary. So actually, for a full implementation, you can try to use a double linked list. This is 1 point. The second point is in the get method. So this part we marked as star should be use caution, right? So we need, after we access one key value pair, so those that key value pair automatically becomes the most recent used ones. We need to adjust the order in the dictionary. And in the put method, so basically, if we have a cache hit case corresponding to the get method, so we need to move the key value pair to the most recent one. And in the cache miss case, so we add a new pair, so we need to increment the size of the cache. And as due to this increment, so we need to check the size against the capacity and pop the least recently used one. So this part, I guess, is exactly least recently used, exactly corresponding to the name, right? The name is least recently used one. So with that said, basically that's about it for this video. Thank you.